Okay, so as I expressed to you yesterday, graphing lines, functions, parabolas, hyperbola, those things all do have some real life applications. So tonight we're going to talk about what those applications are as they pertain to lines. So lines actually do have something to do with your life. They do have real life applications, and hopefully you will see that connection after our discussion tonight. So we're on this page in the notes, and as I talked about yesterday, if you look down at the lines that are graphed on those little graphs on the paper, the pitch of the line is the slope of the line, which is also thought of as your rate of change. So if something is changing very quickly, for instance, then it might be graphed like this, okay, a much steeper line. If it's changing quite slowly, it would be a sort of flat line. So slope is considered our rate of change. The y-intercept, this is where the graph, for those of you who want to take this down, where the line crosses the y-axis. That is known as your y-intercept. It's a very important part of the line, and we'll do a lot with that in the future. The initial value is where your line crosses the y-axis, or that y-intercept. Okay, so that's just some terminology so you will understand what I'm saying as I refer to these lines. So let's see how this works with a real life application. A shoe store offers free points, woohoo, when you sign up for their rewards card. Then for each pair of shoes purchased, you earn an additional number of points. The graph shows the points earned for several pairs of shoes. So for instance, if I have 2 pairs of shoes purchased, I have 60 points. If I have 4 pairs of shoes purchased, I have 90 points. If I have 6 pairs of shoes purchased, 120. And if I have 8, I have 150. Okay, so we're going to talk about how to write an equation to represent the function. The first thing that you're going to want to do is you're going to want to think about the rate of change and the initial value. So what would our initial value be? Well, it's not shown here, so you would have to take a ruler and kind of sketch it out. Okay, you'd have to kind of extend your line and say, oh, where would it intersect the y-axis? It would intersect the y-axis at the point 30. So 30 here, where the line would cross if I had 0 shoes purchased. So if I purchase 0 shoes, I have 30 points. So I think what that's saying is the store will start you off on your card is 30. So we're trying to relate this to a real life scenario. Okay? So they're going to start you off with 30 points, and then you're going to get shoes as you go along. So what is the rate of change here? Well, if I have 2 pairs of shoes, I have 60 points. If I have 4 pairs of shoes, I have 90 points. What that's saying is for every 2 pairs of shoes, I get 30. So for every 1 pair of shoes, I should get 15 points. Okay. So if you think about that, my rate of change is going to be, think about it. For every 1 pair of shoes, I get 15 points. So the rate of change is 15 points for each pair of shoes. Now we haven't really done rates and ratios yet, but a rate is kind of like miles per hour. So points for shoes, for each pair of shoes. Now, an equation of the function means, well, it's my rate of change is this times the x value plus my initial value. That's what an equation looks like. So really, that's the same thing as slope times x plus y-intercept. Okay? So if we look at this particular equation, what is my slope or my rate of change? It's 15 over 1. 15 points for one pair of shoes. So it's going to be y equals 15x plus, what did we say the initial value was? The initial value was 30. Now, if you're confused right now, that is perfectly fine. This is the first time you've seen this, and you've heard me say this before. The first time you see it, it should be a little foreign to you. You should be a little confused. It takes time, experience, and practice to get used to these. All right, so let's try another one. Music Inc. charges a yearly subscription fee plus a monthly fee. The total cost for different months, including the yearly fee, is shown in the graph. So here is the number of months that you belong, and this is the total cost. So if I belong for 1 month, it's $15, 2 months, 18, 3 months, 21. So see if you can determine what the rate of change is there. How much is it changing by for each month that you go, that you have a subscription? All right, so it's going to be, my rate of change is going to be the dollars over the months. Okay, and I'd like to get it down to what it would be. What is the rate of change for 1 month? Now you need to really look at those points. 1 month is 15, 2 months, and you could put this almost in a chart. 1 month is 15, 2 months is 18, 3 months is 21, 4 months is 24. What is my rate of change for each rate of change of 1 month? It's going to be $3, right? So for every month that I subscribe, I pay an additional $3. So the rate of change is 3, or 3 over 1. Write an equation to represent that. Now remember, it's going to be y equals slope times x plus y-intercept. Now we haven't done our y-intercept yet, so our y-intercept is this initial value. What is the initial value? Well, I know that since this is 3, if I subtracted the 3 here, because it's 0 months, okay, I'm going to subtract that, I would get 12, which looks about right. Okay, that means my initial value is 12. So basically what this is saying is it's $12 for the year. I pay $12 for the year, and then I pay $3 a month. So in terms of my line, that's going to be y equals my $3 per month plus my $12 per year. And that represents the line, the function, the situation, the graph. So this line represents all those different things. Let's just take a closer look at that. Y equals 3x plus 12. This is a line. It's a graph that you see up there. It's also this table. Okay, so it's a line, it's a graph, it's a table, it's a set of ordered pairs. In math, we have different representations for things. So I can have all those ordered pairs that are listed above. I can have that table that I've made over there. I can have the graph that is shown to you there. And I can have this equation. Okay, it's all the same representation of the situation that is, what is this, a Music Inc. Okay, that's my real life situation. Amy has photos in her photo album. Each week she plans to add 12 photos, and she has 120 photos after 8 weeks. They're telling you that this is linear. So, what do you think she had in her photo album at the beginning? That's your initial value. So after 8 weeks, she had 120 photos. And she added 12 photos per week. Well, 12 times 8, 8 times 2, 16, carry the 1, 8 times 1, 8, 96. So if she, in fact, added 12 photos per week, she added 96 photos over 12 weeks, right? 8 weeks. So what did she have at the beginning? She had 120 minus 96, which is 24 photos. Oops, sorry, that should not be moving. 24 photos to start. The rate of change is what she added per week. So how many photos were added per week? And how many photos did she add per week? It tells you right there. Per week was 12. And an equation, remember that this is our rate of change, okay? Rate of change plus initial value. So rate of change was 12 x, and my initial value was 24. So again, that is going to represent a line. I could plot some points, plug them in, and represent that with a graph that's going to look kind of like whatever 24 is here. Let's say that's 20, 40, 60. Okay? So it's going to be 24 plus a slope of 12. Well, if this is a number of weeks, it's going to be a pretty steep line, right? Okay. So I could graph it if I chose to. Let's take a look at the next one. A zoo charges a rental fee plus $2 for an hour for strollers. The total cost is $13. Assume the relationship is linear. So what do you think the initial value is? Well, we know what the rate of change is. They're telling us. You all think about it now. What is the rate of change? It is the $2 per hour, right? So that cost, $2 per hour times 5 hours would give me 10. But there was an initial fee, right? Because their total cost is 13. So what was the initial fee? The $3 initial fee for the stroller. That's the flat fee, okay? So an equation that represents this room is going to be my per hour cost, my rate of change times x, plus my initial value. Hopefully now you're starting to get this. And really my objective here for you is to sort of understand how lines, charts, and things like that can relate to a real life situation. This table shows how much money Spencer has saved. Assume the two quantities is linear. So now they're not telling you specifically, but they're giving you a chart. Because remember I said it could be a chart or a table. It could be a graph that they give you. It can be the word problems like we've seen. Well, let's look at this. Okay, for every month Spencer has been saving, how much has he saved? Well, 110 to 130, 130 to 150, 150 to 170. Each month, it looks like he saved $20. Okay, so that's my rate of change. All right, find and interpret the rate of change. It's $20 savings per month. And I can use this slash as an abbreviation, right? That's per month. The initial value then is what? Well, I kind of have to back into it. That means in month 2, he would have saved 90. In month 1, he would have saved 70. So at month 0, how much money did he have before he started saving? He had $50. So $50 is the initial value, which represents his initial bank account or whatever. Money in his piggy bank. Okay, so the equation, see if you can do this on your own. Remember that it's y equals your rate times x, or your slope times x plus your initial value. So that's going to be 20x plus 50. Good? Hopefully by the end of this lesson you understood at least how the representation of a line, which is what we gave you yesterday, can represent a real life situation and can also relate to a chart or a graph. Okay? So have a great night. I will see everybody tomorrow.